Well, g'day, Max here again. Welcome back to the shop. So, hope everyone's surviving their coronavirus thing. I'm not going to go into too much depth about that because everyone else has already done that. Sorry for the delay in the video, but we've had quite a few other jobs that we've had to do. So, of course, we had Rust and Ox's coat hanger, so we got that one done. And then I had to make a Rio bar bender. So I'll give you a quick shot of that one. I think we mentioned we've got 100 Rio bar squares we have to bend up. So we've completed the bender for that, and I'll start bending now up next week. So we'll carry on now. As I've said before, we'll complete the last couple of machining operations on the Arbors before they're ready for heat treat. And one major job to do first is clean up this workshop, which is it's a shithole. There's crap everywhere. So after we've completed the rough boring operation, I switch out the insert to this one with a radius ground on the end of it. Quite a bit larger radius than the standard the radius on these inserts. So that'll give us a good large radius up inside. So we'll do our finished cuts with this. We're just running the tap down all these arbors because as we power tapped them in the lathe, I didn't want to bottom the tap out in the hole. So we'll run the tap down them all and clean them all up to the required depth. Okay, one more of the countless features we've got to do. You don't actually realise how many little bits and pieces there are to machine on these things till you actually go to make them. Well, this is a standard commercial ER40, my Mechanica one. Now, right down the bottom there, where that hole is, that's a tapped hole. It's a M12 by 1.75 tapped hole. It's only tapped in about 20mm deep. And what that's for is you can put a backstop screw in there, and it acts as a backstop for your part, or your cutter, stops things moving. I suppose you could use it as a limit stop if you were chucking multiple parts you were actually machining and didn't have a cutter in here. But anyway, that's what we're going to do with ours, as we are making it the same as the commercial ones. So we'll get our ones chucked up. So we'll drill, counterbore, drill, countersink, and then tap. Now I had to make up an extension for one of my countersinking tools. It's not required with these short ones, but with our longer ones, which we still have two, which are the same as these, we're countersinking a fair way inside. So it's just a simple tool extension I've made up to hold the countersink. So we'll plonk her in. drill our hole to a depth of 25mm. Okay, so what we'll do now is we'll swap our drill chucks over. Now I've just got one of my old relics I've broken out here, which is an old Jacobs, Sheffield, British made, Sheffield, England, Jacobs. They don't make them like that anymore. You can still see the writing on it. Well, you probably can't in the camera. I've had this one since I was a first year apprentice. So, oh, that's what I was going to say, yeah. So I have a socket gripped in the drill chuck. This makes it so I don't have to grip the hardened tang area, the shank area of the tap in a drill chuck, which is not, never a recommended idea anyway, but we all do it from time to time, including myself. And it also gives me the extension I needed when I was to reach in to tap down into these longer arbors. So, I'm just going to push the tap through till the tap starts and gets a good bite in, and then I'll finish tapping it by hand. As last thing I want is a bloody broken tap inside these things. So I've only drilled the tapping size drill to the absolute minimum that needs to be, just to keep a bit of inner core strength in the arbors as well. So. Oops, and we nearly forgot, before we tap, we have to countersink. A bit more. That's good. Now we can tap. That countersink just gives a nice chamfer for the tap to bite into, and saves us having to do any deburring inside as well. That's about as far as I'm game to go. We're there. So we'll finish off with a bottoming tap, plug tap. tapping oil. I think I mentioned before the tapping oil that I always use is it's the oil that I mix with the flood coolant. Good as anything else I've ever used, so saves buying an extra product. I still have that little sample bottle of Stan's anchor lube there, but I'm trying to keep that for stainless steel. I think we're there. Okay, that looks good. So we'll do that to the remaining arbors and then move on to the next feature. Okay, it's Keyway time now. So we've got our indexing head set up and our tailstock set up. So we've indicated our pattern in 2 axes, and what we've got to be very careful of on this one is our cutter, when it's on centre, will just be clear of the top of the tailstock there, so we don't want to be machining my tailstock away. not a good look. So we're just going to clear by the look of this, so we'll have to keep a close eye on that when we're milling. So we'll get the arbor set up with this slitting saw on and cut a keyway. Now we're on to cutting our keyway. So we have the cutter mounted up on our Arbor adapter that we made, and we have checked the run out of the cutter. So that's quite good. It's less than half a thou, so we're happy with that. I think it was about 3.5, 4 tenths, so we're good with that. So our arbor we have set up in the indexing head and supported by a tailstock on the other end. So first thing is to centre the cutter on the same plane as the centre of the shaft. So to do that, we'll just hover the cutter over the top. We're going to pick up off the large diameter here. So we'll bring the cutter over the top of that. We'll just eyeball it in quite close. Somewhere there is pretty close. Yeah, I think we'll be right there. Now, what I'll do is I'll use a piece of cigarette paper, and this is 3/300ths of a millimetre thick. So we'll start the mill up, and when the cigarette paper, when the cutter grabs the cigarette paper, we know we're 3/100ths of a millimetre above the shaft. So we'll crank the mill up. We'll just raise the knee up slowly. There. So we zero the dial on the knee. Now to set the depth of the keyway, we'll wind the cutter in till it just just touches the surface, then what we have to do, now the depth, the specification is given from the bottom of the keyway on an R8 Arbor to the underside of the shaft. So in essence, we're measuring from here to the underside of the shaft. Now, our shaft is oversized, so this is where we've got to be careful. So the shaft diameter at that end there should be 949 thou. Now, ours is 961 thou because we're up on size because we have a grinding allowance. So what we have to do there is we subtract 949 from our 961, gives us 12 thou. Now we divide that into 2, gives us 6 thou. So what we're doing is we're adding half of the diameter difference to the depth of the key. So now I'll do this in pen so you can see a bit better. So in essence, that's the dimension that we need there. Now, if this diameter here, say, was our finished size of 949, in reality our size that we're working with now is 961. So we need to add this portion on, which is why we add half of the difference in diameter. Okay, so then what that does then gives us our diameter 856, which is the dimension given on the print for an R8 from the base of the key to the bottom of the finished size of the shaft. Then we add on our 6 thou, which is half of the difference in diameter. Okay, that will give us a dimension of 862 thou. We have to measure from there to there. Now, because we can't measure inside here, what we're going to do is drop a thread wire in there. Now the wire we're going to use is 127 diameter, so we add that to our 862, gives us a total dimension taken off the top of the wire to the base of the shaft here, 989 thou over the wire, or 25.12 millimeters. So that's how we get our depth. It's just got to be a bit careful because we are dealing with a finished dimension here and an oversized dimension here, so you've just got to take that into account. So we'll get set up back round at the cutter, we'll touch off the cutter and wind the cutter into depth. Now to find out the depth that we have to wind the cutter in from there to there, so we're after this dimension here. So we've touched off our cutter there, and what we need to know now, the original depth of the keyway on the finished size shaft is 856 thou. So if we deduct the finished size of the shaft, which is 949 thou, if we deduct 856 thou, that gives a dimension of 93 thou keyway depth from here to here. Now because our shaft is oversized, like this part diameter here, it's 12 thou oversized, so we halve that, which gives us 6 thou that we have to add on to this dimension here. So we end up with 93 thou plus our 6 thou, so it gives us a total of 99 thou, or 2.514 millimeters from when we touch off to our depth. Now when we touch off on the keyway, we're looking at a dimension, that's the key. We're not looking at the point there where the cutter touches, we're looking at the point where the cutter comes into full contact, so it's the depth of the side of the key. That's the dimension where we will set our 0 point. Then we'll take our depth of 2.514. We're just touching there. So we want to wind in until we see the cutter cutting the full depth. Fraction more. I'd say about there. So we have full contact with the cutter there now. This is another time to do an anti-bozo check on our centre height. Good visual, and also check to make sure we haven't got any sort of thicker edge on one side than the other. And I think we're right on the money there. So we'll bring the cutter back to the end and wind in for our depth of cut. So I'll start the mill to come back over there because we don't want to drag the cutter over the surface without it running. And at this point I'm going to set our axis to 0. If you had a DRO, this is where you'd hit 0. We'll just reposition our cutter at the beginning of the cut. Okay, now we wind in now our required depth, which is 2.54 millimetre. Okay. It's 1 millimetre. Just making sure we're all clear. It's 2 millimetre. I'm going to have to start cutting, and then we'll increase our depth once we get in a bit further, because I'm starting to get a bit close to the everything here. still to go 0.551 millimetres. So we're in 2 millimetres, so we'll take the remaining half a millimetre. Okay, that's right on, we're at full depth now, so we'll take the cut. Okay, we're at the length that we need to be. We'll just back the cutter out. Now we did climb mill all of that. Climb milling is the best way with a slitting saw most of the time. Depends on your setup and your mill. As long as your table and all your gibs are adjusted right up, climb milling's fine. If you're new to milling, I probably wouldn't do it. I'd recommend upcut milling, so you'd have to cut the keyway from the other side. So your cutter's rotating the other way and cutting up into the part. That'll eliminate any chance of the cutter grabbing the part and smashing the cutter. So we'll clean this one up. We'll take a trial measurement to see how we're going. Now we'll just get a check on to see how we are. Wiggle it around so we get a good feel. We're 987. So we've overcut only by 2 thou. So that's okay, good enough. 2 thou's nothing in a depth of a keyway on an R8. So what we can do is just take note of our depth on our crossfeed end, and we can just make an adjustment to that for the other arbors, but it's, like I say, it's not really that necessary. The other thing to look at too, which is another indicator that you're on centre, is you'll have a slight radius here where your cutters, the end of your cutters come to your shaft, and if that looks all symmetrical there, you are right on centre. So we've got a nice finish in there. So good result. So we'll run the rest of the cutters through at that and move on with the next operation. Okay, we're up to the stage now to mill these spanner flats. We're going to do our ones a little bit different than the way these ones are done. We are going to mill them a bit closer to the end here, so the tool can be dropped into a holder and the nut tightened up if necessary, that way. So we've just got it set up the same as before in the indexing head and the tailstock. Now what we've done on the end here, because we've rough bored the collet chuck already, we're able to get our ER40 collet inside. Now I have a dowel inside the ER40 collet, so when that tailstock pushes up, the collet's got something solid to clamp down onto. Now this end mill will ring a bit. You'll notice what it is. I've got 3.5 inches sticking out here. It doesn't need to be there. It's because I've had to. This is a ER32 into an R8 adapter, so that gives you a fair bit of extension, which is asking for a little bit of ringing, which is what we will get until such time we get these things finished. It's up in there. I have ordered a set of Bridgeport collets, R8 collets, to go up the spindle here, and they're coming from all industrial over in America, so they'll be some time before they arrive, as we can't get them locally here. So anyway, let's get the spanner flats milled. Having said it's going to start ringing and chattering, I was not going to do it now. So just a small point here. We've milled from the other side through to this side because the rotation of the cut is coming around this way. So what that'll do is we don't have a burr, an overhanging burr on the edge here to pull any. It's cutting into the edge, so we don't get the burr. So just a small point. So we'll just traverse across and come back the other way. And the last cut. Okay, so we'll just double check our size. So 45.9998, so that's fine. We're going for 46 mil across the flats, so as long as we're just under 46, we're fine. So with these, we'll just hand file a bit, hand file this radius around. I'll swing it around here, just to match up with this radius. Now I could have done that with a corner rounding end mill, but then I've got to keep swapping end mills for the corner rounding one every time, so I'm just going to file that by hand. We have to drill and tap the holes in the face mill arbors for the cap screws here to hold the locking keys. So we have our face mill arbor set up in the indexing head and tailstock, and we have a piece of tool steel here, So a bit of 3/8 tool steel. So we're just running our indicator up and down that, which we have in the quill. We use our star at last word, and we can run that up and down to put our keyway in a perpendicular fashion. Now, to get the last piece of adjustment, if you end up in between holes on our circle here, this dividing head has this feature here, so I can slacken off the screw and pull the slide out and just slightly move the indexing plate either to the clockwise or anti-clockwise until everything lines up. So it's a handy feature to have. So she's all square now, so we'll get a drill set up and drill and tap these holes. So the hole that we have to drill and tap, the end of the keyway here, we have a dowel pin, a 3/8 dowel pin, which is a tap and fit to the keyway. So we've just indicated that in, and that'll put us on the centre of the radius of the end of the keyway slot to drill and tap our hole. We're just tapping the number 10 UNC threads into the face mill arbors for the cap screws to hold the drive keys in position. So I've already drilled them, and then I've gone back in with a centre drill to chamfer the edges of the hole. So we'll just run the tap through. Just doing this by hand. It's only a very small tap and quite tough material. And I don't have the kahunas to power tap it, so yeah, what I'll do now is I'll finish it off with the tap wrench. Now it's all started square. This gives you a bit better, or gives it a bit better feel on what's going on. We don't want any snappy, breaky business going on. Feels like we're through. Yep. Okay, success. Okay, we're up to our last operation now. So we have to drill the 6 holes on the boring head arbor, just so we can pick up on these holes here. So we've got the arbor clamped up in the chuck. Everything's centered in. So all we'll do now is we'll centre the arbor under the quill, and then we'll step over so we can pick up on our PCD. So to get it centred under the quill, we'll just use our last word. So we're smack on centre there. So all we'll do now is work out our pitch circle diameter. We'll step the part over half of the PCD, and then we're in the right spot for drilling, and we'll just index using the rotary table the 6 holes. Okay, so a quick easy way to pick up on what our PCD is. We've put 2 of the mounting cap screws in. So we'll just sweep across till we get our largest measurement, which is 59mm, minus 1 complete diameter of the screw, which is 5mm. So that gives us a PCD of 54mm. So half of 54 is 27. So we'll step the table across 27mm. Okay, here's where things can go a bit wrong on you if you're not careful, especially with us guys that don't run DROs. If you've got a DRO, you'd zero your DRO now and move the table across. Easy. The other option, I could use a long travel indicator and take my reading directly off that. Then I'd have to swap the indicators over and use my other mag base. Or I've just zeroed the indicator on the hand wheel. It can be anywhere as long as it's somewhere. Perpendicular, 0. Now we have our dial here on 0, but what we don't know, because I can't remember, can you? Which way we wound this handle last when we were centering the part. So what this allows me to do now, because I have to move across 27mm, I've got a 50-50 chance that my backlash is going to go the wrong way. So I'll just see which way it's going to go. Well, okay, we won that time. But say we were going the wrong way, we'll come back to 0. Say I wanted to step the part the other way. I'd have to overcompensate and then come back to 0 on here and then reset my 0 on here. See, I'm point 0.33 out on here, and that's the backlash in my nut. So it's just something to be wary of. So we'll set back to 0 here. We're still on 0 there. So what was it, 27mm? So we have a 5mm pitch lead screw, so that's 5, 10, 15, 20, 25, 26 and 27 on the dial. Okay. So bring it up, bring the quill down. So we'll get a center drill in the quill, and we'll just spot mark our first side. We'll come around 180 degrees, spot mark our second, and just double check our measurement. And we're right on it. So we can safely go ahead now and drill all our holes. Okay, that's the last operation in the machining part of the series, so I'll drill the rest of those holes off camera, as this video is starting to get a bit longer than what I anticipated. So everything's, well, I'll drill them off camera, so once they're done, deburred, I'll just take all of the arbors, I'll give them a final inspection, make sure there's no burrs or anything like that on them, give them a good wash up, and then we're ready for heat treatment. So the next video is going to be our heat treatment session. So stick around for that, and it could be interesting. It's a lot of new ground for me, so we'll see what happens. So take care, take it easy. We'll see you on the rebound.